Okay, next example, a little bit more complicated but very similar to the previous example, okay? We've got M1, M2, M3, and M4. M1 and M2 each have a mass of 35 kilograms. M3 has a mass of 60 kilograms, and M4 has a mass of 20 kilograms. The separation distance between M1 and M2 is 4 meters. The separation distance between M1 and M4 is 4 meters. So they're in kind of a square-like configuration with one mass at each one of the corners of the square. In this problem, we want to find the net force on M3 in unit vector notation. So we're trying to figure out the net force on that guy, okay? Before we do anything, and again, you can pause if you want to try this problem first and then watch my explanation, so go ahead and do that. Before I do anything in this problem, I'm going to analyze the direction of all the forces, just to take a look at it. So M4 is going to pull up on M3. They're going to attract each other because of the force of gravity. We are interested in the force of gravity on M3, so M3 is going to be pulled up by M4. M3 is also going to be pulled to the left by M2. Okay? So those two guys are very straightforward. I know the distances between those two guys, and one points directly up, one points directly left. That's nice and easy. This right here is the hard one. M1 on M3 is going to pull M3 up and left. So M3 is going to be pulled up and left right there. Because it's pulled up and left, that means that its force of gravity has components, x and y. So I need to calculate the force of gravity, then calculate the components, and add them to the component along y for M4 and the component along x for M2. So that's how I need to solve this thing. I need to figure out these force of gravities first, then figure this one out, break it down into components. Okay? So let's go ahead and do that. And notice my notation on these types of problems. I try to use the same notation over and over again. I talk about the force on M1 from another M. Okay? So, the force that M2 exerts on M3. So notice the notation. The force that M2 puts on M3, so that's this guy right here. That force of gravity is going to be 6.67 times 10 to the minus 11. Yes, you're going to use that constant over and over again. We need the two masses. M3 is going to be 60 kilograms. M2 is going to be 35 kilograms. And the distance between them is 4 meters. So we're going to have 4 squared. So that force of gravity from M2 on M3 is 8.75 times 10 to the minus 9 newtons. And that's in the minus x hat direction. So that's directed to the left. That one's pretty easy. Okay? Now, the force from M4 on M3. Okay, so this is M4 on M3. It's the force that's taking this guy up. So that should be along the y direction. That's going to be 6.67 times 10 to the minus 11 multiplied by the mass 3 is 60 again. Mass 4 is 20 divided by the distance, which is 4 squared. Okay, so this force of gravity is going to be 5 times 10 to the minus 9. To the minus 9 newtons, and that's in the positive y-hat direction. The positive y-hat direction, because it's pulling us up. Okay. Now I need to figure out what is the force of gravity on M3. And I would ask you guys, if we were in class, what is the first thing I need to figure out? I'd put a dramatic pause on it, and I would wait for somebody to say, you need to figure out the distance between M1 and M3. It's not 4 meters, it's the diagonal of the square. So if you do 4 squared plus 4 squared equals c squared, a squared plus b squared equals c squared, you should see that this distance is actually 5.66 meters. 5.66 meters. So the force that M1 exerts on M3 is equal to 6.67 times 10 to the minus 11 multiplied by M3, which is 60, multiplied by M1, which is 35, divided by 5.66, the quantity squared. That is the distance from M1 to M3. Solving for this force, force of M1 on M3 is equal to 4.37 times 10 to the minus 9 newtons, okay? Now that is directed along the line connecting M1 and M3. So that means I have to break this sucker down into components. Thankfully, the angle is very easy to figure out. The angle down here between that force of gravity and the x-axis, dramatic pause, that angle is 45 degrees. Okay? So if I use the sine and cosine, I should be able to figure out the components. Now notice that since I'm using sine and cosine of 45, the components are both the same. So if I break this down into components, it should be fairly straightforward. So the force of M1 on M3, and let's just use the x component, would be equal to 4.37 times 10 to the minus 9 multiplied by the cosine of 45. Okay? So we multiply that by the cosine of 45 and we get 3.09 times 10 to the minus 9 newtons. Okay? So that is the force of gravity from M1 on M3 along the x direction. The force of gravity from M1 on M3 in the y direction is going to be exactly the same because I'm just going to use the sine of 45. Okay? So I'm also going to get 3.09 times 10 to the minus 9 newtons. So with these two guys, I'm going to add them to these two over here because this one was already pulling us to the left. This one's up and left, so I'm going to add the two lefts. This one's already pointing to the right. This one's pointing up and right, so I'm going to add the two ups. So I should get that overall, the net force in the x direction, I'll just put the answer over here. If I add up my two x component forces, the net force in the x direction is negative 1.18 times 10 to the minus 8 newtons. And then the net force in the y direction is equal to 8.09 times 10 to the minus 9 newtons, okay? So we add up the x components because they're both left, and we add up the y components because they're both up. Now I have my answer in unit vector notation. Again, the problem's fairly straightforward. These two forces were easy to figure out because they're all along one direction. Haha, there's a joke in there about a famous band. This one is going to be pointing up and left. You need to break that guy down into components. Just need to make sure you figure out that distance between M1 and M3 first.